All right, let's be real for a second. If you've spent any time writing asynchronous Swift, you know the absolute pain that error handling can be. Well, today, we are cutting straight through all that complexity. We're going to see how async and await completely transforms that messy problem into something, well, something actually elegant, structured, and way more predictable.
And here's the promise, and it's a big one. No more messy callbacks. No more pyramid of doom. No more confusing completion hammers. Seriously, Swift's modern concurrency model lets us write async code that reads just like simple top-to-bottom synchronous logic. So how does it pull this off? Let's dive in.
You know, to really get why the new way is so good, we kind of have to remember how bad the old way was. Think about it. Error handling used to be this tangled web of complex patterns, right? It made code a nightmare to read, let alone debug. That's the world we're coming from, and that context is exactly what makes this new approach feel so revolutionary. So the big question is, how did Swift actually solve this mess? Well, it all boils down to two incredibly powerful keywords that work together perfectly: async throws and try await. These two are the absolute bedrock of this entire new system. So let's break them down.
Okay, so everything starts with how you declare a function. When you add async throws to its signature, you're basically putting up a big, bright sign for the Swift compiler. You're telling it, hey, just so you know, this function is asynchronous and it might fail. You need to be ready to handle an error if you call me. And this is how you respond to that signal. The try-await combo is just brilliant. Think of it like this. Await tells your code, okay, pause here and wait for this async thing to finish. Then try chimes in and says, and while we're waiting, I'm fully aware this thing could throw an error and I'm ready for it. It's the perfect 1-2 punch.
And just look at how beautifully this all comes together. A single clean line of code. Let data equals try await fetch data. That's it. It's so readable, it's concise, and it tells you everything you need to know in an instant. We're waiting for something, and that something might fail. I mean, this is a massive leap forward from where we were.
Okay, so we know how to call a function that can throw an error, but what happens when it actually, does? We need a strategy. The good news is Swift gives us a whole toolbox for this, and knowing which tool to grab for which job is absolutely key to writing solid, robust code. This table pretty much lays out our three main options. First up, you've got your classic do-catch block. This is your heavy hitter. It's for when you need to handle things in detail, inspect the specific error, and react accordingly. Maybe you show the user a specific message or even retry the operation. Then there's try what? This is for when you honestly don't care why something failed, you just care that it failed. It just hands you back a nil. Super simple. And then there's try ying.
Listen, I really can't stress this enough. Using try is like hitting the big red button. It's the nuclear option. You are making a promise to the compiler that you are 100% certain this will never fail. And if you're wrong, your app crashes instantly, no second chances. So unless you have an absolutely ironclad, can't possibly fail guarantee, just stick to the other two, please.
But here's the thing. This is about so much more than just some new syntax. There's a much deeper, much more powerful concept working under the hood here. It's called structured concurrency. And honestly, this is the real magic that makes the whole system safer and more reliable than anything we've ever had before.
So you might be wondering, what is it that makes this new way so much safer? What's the secret sauce? Well, the answer is all about how errors travel through your app. They don't just disappear into the void anymore.
This visual here shows it perfectly. So imagine an error gets thrown way down deep inside some task. In the old days, it might just get lost. Not anymore. Now it automatically travels up the chain, from child task to parent task. This means the parent always knows when one of its children has failed, which lets you handle that error at whatever level makes the most sense.
And that's the bottom line, right there. This automatic propagation means you literally can't ignore an error by accident anymore. The system forces you to be deliberate about it, and that makes your code so much more predictable, way more robust, and just fundamentally safer.
Okay, so let's pull all these ideas together into a simple, clean blueprint. If you can keep these key principles in mind, you'll be writing fantastic, robust, and super maintainable async Swift code before you know it.
All right, here are your 4 golden rules. Rule number 1. If a function can fail and it's async, mark it with async throws. You're signaling its intent.
Rule 2. When you call one of those functions, always use try-await. You're acknowledging that intent. Rule 3. Your go-to should be do-catch. It gives you the most control for proper error handling, so you can give your users useful feedback. And finally, Rule 4. Just avoid try/. Seriously. Unless failure is literally impossible, don't touch it.
So when you put all of these pieces together, it becomes really clear that async await isn't just some new syntax we have to learn. It's a fundamental shift in how we think about this stuff. It takes error handling from being this annoying afterthought and makes it a first-class citizen, transforming those tangled messes we used to write into genuinely elegant, maintainable code.
So, there you have it, the tools, the blueprint for writing safer, cleaner async code. It's all right there. The only question left is, what are you going to do with it? Where are you going to start? Which piece of messy, old callback code are you going to go transform first?